Good afternoon. We are now on to question 2 of this paper. I'll just scroll to the correct one and get started with it. So, questions about temperature changes. Student investigated the change of temperature of a solution. So they're investigating the change of temperature of a solution when different masses of ammonium nitrate were dissolved in water. So it gives you a method, and then it asks that first question of give the independent variable and the dependent variable in this investigation. Now, it says that it's investigating the change in temperature of a solution and masses. And we can also say that we've got a table here which has mass of ammonium nitrate in grams and lowest temperature of the solution. Now, because we've got this here as a table, the first column is usually the the independent variable. So this will be our independent variable. And this will be our dependent variable. So the first one is normally independent, the second one is dependent. Independent is the thing that you are changing yourself, and dependent is the thing that you are measuring in response to that. It then asks us to draw a graph, and the graph will have a nice straight line. I think there's going to be one of the, at least one of the points is anomalous, if I remember rightly. Quite difficult to draw that on here, so I'm not even going to attempt it. But in order to get that right, you have to put the points in the correct place and give a line of best fit. You have to extend that line of best fit in order to answer this question. It says you should extend your line of best fit, and all that means is your line of best fit may end here, so for example here, and what you're going to do is you're just going to extend that upwards to sort of here to make sure that you then get the answer. It's called extrapolation. Now you can see why I don't draw straight lines with this, because it's really, really difficult. So the initial temperature of the water you should get at about 19.6 or so. I'd say plus or minus 0.4 degrees is probably going to be okay. But you have to have it through the extrapolation of that line. You have to have extended your line of best fit up to the temperature. One of the marks is for extending that line, and the initial temperature of the water is going to be that second one. So how do the results show that dissolving ammonium nitrate in water is endothermic? So let's pretend that this is the line here. What we can see, as the mass of the ammonium nitrate increases, the temperature decreases. So as I add more ammonium nitrate, the endothermic reaction happens and it cools it down. So let's put that into words. The higher the mass of ammonium nitrate, the lower the temperature. Okay, so that's 2.4. Now the student repeated these experiments 3 times, or 3 more times, and this shows the results for 8 grams of ammonium nitrate. So the student recorded the mean lowest temperature as 16.5 plus or minus 3.5. So what's that plus or minus 0.3 degrees centigrade? Now, what that's for is that is the range around the mean. So we can see 16.5 is our mean, and the lowest that we've got is 16.2, which is minus 0.3, and we've got 16.8, which is plus 0.3. So this shows the spread or range of the data. And just to add that little bit, because it's a 2-mark question, just saying the lowest is 16.2 and the highest is 16.8. Okay, now what is the type of error shown in table 3? Now table 3 is this one here, and we can see that it's just varying slightly. So this would be a random error, just something that happens. The way we can reduce the random error is to do it more and more and more times. It's not a systematic error, because if it were a systematic error, that error would be constant, as well as if it were a zero error. A zero error is where when you have an instrument, you don't zero it properly and it's slightly off, and it will always add that zero error or take away that zero error from your answer. So that's question 2.